Let's start with Enterprise Architecture, or E. Think of it as the overall blueprint for how your whole organization works, from strategy down to individual systems. It's not just about pretty diagrams. It's a way to make sure your IT investments are actually supporting your business goals and helping you achieve what you set out to do. We'll break it down into 4 key areas: business, data, applications, and technology. Each of these layers works together, and EA helps us streamline processes, cut costs, stay compliant, and ultimately be more adaptable and innovative. Okay, let's talk about what you really get out of enterprise architecture. It's not just a bunch of frameworks, it's actually about helping your organization move in the right direction. When done well, EA helps you make sure IT investments are directly supporting those big business goals. Plus, it can really cut down on costs by eliminating waste and streamlining processes. EA also creates a clearer path for innovation because you have a solid architectural foundation to build upon, and ultimately leads to quicker adaptation when things change. Okay, let's talk about how maturity models fit into the bigger picture of TOGAF and Zachman's frameworks. Think of these frameworks as providing the what, the goals, and the how, the process, while maturity models help us track our progress towards those goals. Models like CMMI or Gartner's Zachman give us a way to assess where we are, maybe level 1, level 2, or even striving for level 3 or 4. Understanding these levels allows us to identify gaps and build a clear roadmap for improving our IT architecture over time. It's about moving from simply doing things okay to truly excelling. Okay, let's talk about TOGAF. It's a really popular framework for building IT architecture in big organizations. Think of it as a roadmap, a structured way to plan and manage how your technology supports your business goals. At the heart of TOGAF is something called the Architecture Development Method, or ADAM. This isn't just a checklist, it's a phased process that guides you from understanding where you are now to designing what you want to be. It also relies on an architecture repository, like a central database for all your architectural plans and documents. And finally, there's the CAF, which helps you figure out what needs to change. TOGAF is designed to be flexible and fit different organizational contexts. Let's dive into the TOGAF Architecture Development Method, or ADAM. Think of it as a blueprint for building and maintaining your IT architecture. The ADM breaks down the process into 8 distinct phases, starting with defining the scope and what you're trying to achieve, the prescription phase. Then, we create an architecture vision, a clear picture of where you want things to be. We gather insights from stakeholders through workshops, assess the current state, design detailed components, plan for implementation, validate changes, and finally, establish ongoing governance. It's a robust framework, but remember, adaptability is crucial. Tailor TOGAF to fit your unique circumstances. Okay, let's talk about the really important piece of the TOGAF puzzle, the content meta model. Basically, it's like a universal dictionary and grammar for architects, a shared language that helps us all understand and describe enterprise architecture consistently. It breaks down everything into building blocks: artifacts, which are things like documents, or diagrams; concepts, which are abstract ideas like customer or process, and then the relationships between them. This framework ensures we can reuse components easily and track how different parts of our architecture connect back to business goals. Let's talk about the heart of TOGAF, the enterprise continuum. Think of it like a journey, not just a static blueprint. It's an iterative process that guides organizations through architectural evolution. The continuum is made up of 5 phases, each building upon the last, from defining initial scope to implementing and governing the architecture. And to keep everything organized, TOGAF uses something called the repository, which isn't just a place to store documents. It's a structured collection of all the architectural artifacts needed throughout the entire process, including models, standards, and guidelines. Okay, let's dive into the core of TOGAF, how it really works. You'll notice that the ADM Architecture Development Method is a fantastic framework, but it needs something to guide it. That's where the reference models come in. First, we have the TRM, the TOGAF reference model. Think of it as a collection of blueprints. It's broken down into 4 key areas: the business model, process reference models, data dictionary, and technology framework architecture. Each area provides reusable architectural components and patterns to help you design your IT landscape effectively. Then there's the Roman 3RM, the Integrated Information Infrastructure Reference Model. This is a more detailed version of the TRM specifically focused on how data, applications, and technology all fit together within an enterprise. It has three main views: data, applications, and technology. Using these models helps you align your IT architecture with your business strategy, leading to better decisions and less rework. Okay, let's talk about TOGAF's capability-based planning. This is a really important step in the process. Instead of starting with technology and working asterisk down asterisk to business needs, we flip it around. We begin by identifying the core capabilities your organization actually delivers. These are the things you do well, like onboarding new customers or processing orders. We map these capabilities across different parts of the company, then figure out where there's a gap between how you are doing things now and how you want to be doing them in the future. This helps us create an architecture roadmap that directly supports those strategic business goals. Okay, let's talk about governance within the TOGAF framework. Think of it as your architecture's rulebook. It's how you ensure everyone is working towards the same strategic vision. We have an architecture council that steers the ship and a governance board that oversees how we govern. It's all about clearly defining who's responsible for what, establishing consistent policies and standards, and keeping stakeholders in the loop through regular communication. A well-defined governance model helps you stay on track, mitigate risks, and ultimately deliver more value from your IT architecture investments. Okay, let's talk about TOGAF's views and viewpoints. Basically, TOGAF helps us tackle huge architecture projects by breaking them down into smaller, more manageable pieces. Think of these pieces as views. A view is like a specific perspective on the architecture. It shows what's important to different people involved. For example, we might have a business architecture view that looks at how technology supports business goals, or a data architecture view that focuses on data management. Now, viewpoints are the drivers behind these views. They're like lenses. They help us frame questions and understand the context for each view. They answer why and how. So, a viewpoint might ask, from the CIO perspective, how does the system contribute to our overall strategy? Or perhaps, considering security regulations, what data protection measures are needed? The views then build upon these viewpoints, providing a complete picture for all stakeholders. It's really about focusing on the right things and making sure everyone is on the same page. Let's dive into the Zachman framework. It's a really helpful starting point for thinking about IT architecture. Essentially, it provides a structured way to map out all the pieces of your systems and how they relate to each other. The framework centers around 6 key dimensions: data, function, users, requests, allocation, and deployment. Each dimension is then viewed from 3 different levels of detail: conceptual, logical, and physical. You can think of it as a 6-6 grid that helps you see the whole picture and understand how everything fits together. Let's dive into the Zachman framework. It's a really helpful way to think about your IT. Basically, it breaks down all the knowledge needed for effective architecture into 6 key dimensions: whether you're building like a CRM system or a mobile app, how you build it using processes and technologies like agile development or cloud infrastructure, where things exist that could be data centers, cloud regions, or even user devices. Who's involved: developers, admins, analysts, the whole team. When activities happen: release cycles, maintenance windows, project timelines. And finally, while you're building it all, what business goals are driving your architecture decisions, like increased revenue or improved customer satisfaction. Okay, let's dive into a key part of understanding IT architecture: the Zachman framework. This framework breaks down architecture across 6 dimensions to offer a holistic view. But for this slide, we're focusing on 5 crucial perspective roles: planner, owner, designer, builder, and subcontractor. The planner sets the big picture and overall goals. The owner is ultimately responsible for success. The designer translates that vision into detailed designs. The builder actually puts those designs into practice. And finally, the subcontractor handles specialized tasks. Think of it like a project team. Each role has specific responsibilities and a key focus dimension to consider as they work. Let's talk about how TOGAF and Zachman differ. Essentially, TOGAF is like a detailed blueprint for your entire IT strategy. It's all about getting things aligned with the business goals step by step. Think of it as building a house with a clear plan for each stage. Zachman's model, however, is more data-focused. It's like a really comprehensive database schema that describes how everything should be organized and documented. They both have their strengths, and often organizations will use elements from both to create the best architecture solution. Let's talk about FEAF, the Federal Enterprise Architecture Framework. Think of it as a roadmap for how federal agencies can approach IT, making sure everything works together smoothly and supports the overall goals of the government. It's built around three main things: the core architecture framework, which provides a shared model for building systems, a set of guiding principles to drive decisions, and an architecture capability framework that outlines how to build and maintain a strong architecture practice. Importantly, FEAF isn't about rigid rules. It's more like a helpful guide. Agencies can tailor it to fit their specific situations. Let's talk about TOGAF. It's a really interesting framework specifically designed for the Department of Defense. Think of it as a way to build architectures that directly support mission goals while keeping security at the absolute forefront. Unlike some broader frameworks like TOGAF or Zachman, TOGAF isn't just focused on technology. It takes a holistic view, considering everything from people and processes all the way down to specific systems. It uses a layered approach with different views to capture architecture elements in ways that are most relevant. It's really about ensuring that its investments are perfectly aligned with strategic defense objectives, and its documentation process is incredibly thorough. Okay, let's talk about MODAF. It's a really interesting framework. It's essentially an adaptation of TOGAF, but with a very specific focus. Think military systems and operations. That's where MODAF comes in. Unlike some other architectures which prioritize strict processes, MODAF really emphasizes how things need to work in practice, making them adaptable and resilient. It's designed to cover the whole life cycle of a system, from when it's first conceived right through to when it's retired. Key differences include a greater focus on operationality, a strong emphasis on the entire life cycle, and a real need for everyone involved, military personnel, industry partners, and government, to have a common understanding of how things connect. Okay, let's talk about Gartner's enterprise architecture approach. It's really quite different from some of the more structured frameworks like TOGAF or Zachman. Instead of a rigid process, Gartner focuses on delivering real business value. Their core idea is value-driven architecture, basically figuring out which architectural investments will have the biggest impact for your company. They take an iterative approach, starting small and expanding as you go. Collaboration with both business and IT teams is absolutely key. It's all about making sure everyone understands what they're working towards. And importantly, Gartner recognizes that there isn't a single best architecture it needs to fit your specific situation. They use tools like architecture assessments and roadmap development to guide the process, always keeping in mind where you want to be and how to get there. Okay, let's talk about ArchImate. Think of it as a visual language specifically designed for architecture, whether you're looking at your business processes, the way your applications are built, or even the technology infrastructure supporting everything. It provides a standardized way to represent all those different aspects and how they relate to each other. Essentially, it uses building blocks called elements like processes or organizations, and then defines how these elements connect through relationships like uses or supports. There are also different diagram types you can use depending on what area of architecture you're focusing on. Let's talk about ArchImate. It's a really helpful tool for seeing the bigger picture of how your organization works. Think of it as a way to map out everything from high-level business strategies all the way down to the specific IT systems that support them. ArchImate breaks things down into key viewpoints like business, IT, software and technology, helping you connect these different areas. It uses a simple set of symbols, processes represented by circles, functions by rectangles, and arrows for relationships, so it's actually pretty accessible to folks from many different backgrounds. You can find more detailed information on the Archimate website if you want to dive deeper. Okay, let's talk about Archimate. It's a really powerful tool for understanding how your entire organization works, not just in isolated departments. Think of it as a map that shows how your business strategies connect with the applications you use and the technology that powers them all. We break it down into three main layers: the business layer, which describes your goals and processes; the application layer, detailing what software is actually running; and finally, the technology layer, focusing on the hardware and infrastructure supporting everything. It's a great way to get a complete picture of your IT landscape, a truly holistic view. Okay, let's talk about it for IT. It's a really important framework for modern architecture. Think of it as building on the solid foundations of TOGAF and Zachman. Those are great starting points. But IT for IT takes things a step further by making sure the architecture we design actually delivers value to the business, like better efficiency or faster product launches. It uses pre-built components called reference architectures, kind of like a library of building blocks that you can adapt to your organization's specific needs. The Zachman framework helps us understand all these different perspectives: what's happening in the business world, what data we have, how our applications are structured, and what technology is powering it all. It's about connecting architecture with tangible outcomes, a key difference from purely design-focused approaches. Okay, let's talk about the C4 model. It's a really handy tool for visualizing software architecture, and it's all about breaking things down into 4 different levels of detail. Think of it like zooming out to see the big picture of your business and users on level 1, then zooming in to look at the components and how they work together, right through to where those components actually live, level 4. It's a fantastic way to communicate architecture clearly. Okay, let's talk about the 4+1 view model. Think of it as an expansion on TOGAF. It takes the basic context diagram and adds 4 more layers: a logical view that describes what the system does, a development view outlining how it's built, a deployment view showing where it runs, and finally, a transition view mapping out the steps for moving to a new architecture. Each view offers a different lens through which to understand the whole picture, helping architects communicate effectively and plan carefully. Okay, let's talk about the toolbox for enterprise architecture. There are quite a few different types of tools out there that help us build and manage our organization's IT landscape. We have modeling tools like Enterprise Architect or Archimate software, which really let you visualize everything, how your components connect and flow together. Then we need collaboration platforms like Confluence or SharePoint to keep everyone on the same page when sharing models, documents, and discussing ideas. Requirement management tools such as Jira help us track what needs to be built, link it all back to our architecture, and manage changes effectively. Finally, there are analysis and simulation tools that allow us to test our designs before we actually build them. It's really about finding the right combination of tools to fit your organization's specific needs. Okay, let's talk about managing your architecture repository. Think of it as the brain of your enterprise architecture, single place where everything related to how you design and build your IT systems is stored and organized. It's not just about dumping files in a folder, it's about having a structured system with clear metadata, version control, and proper access controls. Maintaining this repository, making sure it's searchable and accessible to the right people, is absolutely critical for consistency, traceability, and ultimately successful architectural governance. Okay, let's talk about architecture governance and review boards. Think of these as the steering committee for your IT architecture. You have a governance board that sets the strategic direction. They decide what you're building and how it aligns with business goals, and they control the resources needed. Then there's a review board, which is more focused on the technical details. They make sure everything is built correctly according to established standards and identify any potential risks. These boards are usually made up of people from both the business side and the IT side, ensuring everyone's voices are heard. They'll be reviewing designs, approving roadmaps, and checking that things are actually being done as planned. Integrating TOGAF and Zachman helps give them a really solid framework to work with. It's all about structure and process. Okay, let's talk about architecture road mapping. It's essentially creating a strategic plan for how your IT architecture will evolve. Think of it like drawing a map to guide you through a complex journey. We look at different approaches. TOGAF suggests breaking down architectural work into phases and steps. The Zachman framework uses perspectives to ensure we're considering everything from data to people. Then there's the Strangler Fig pattern, which is all about gradually replacing old systems with new ones. It's a slow but steady approach. And finally, value stream mapping can help us understand how value flows through our processes and identify areas where architecture improvements can make a real difference. Remember that your roadmap needs to be flexible. Things change, so you want something adaptable. Okay, let's talk about keeping your IT architecture on track, specifically around compliance and risk. It's not enough to just design a great system. You need to ensure it actually meets its goals and doesn't introduce unnecessary problems down the road. TOGAF emphasizes that adherence to their architecture development method is key to achieving this. Zachman's framework helps us look at things from different angles, ensuring we've covered all the bases. We need to actively identify potential risks, things like security vulnerabilities or performance bottlenecks, and then create strategies to mitigate them. A robust governance process, with clear policies and controls, is absolutely vital here. Finally, remember that compliance isn't a one-time thing. It requires ongoing monitoring through regular audits and integrated into your change management processes. Okay, let's talk about ADO architecture decision records. Think of them as mini postmortems for your architecture. They're super valuable for teams working on complex systems because they force you to think critically why you're making a particular architectural choice. Essentially, an ADR captures the why behind decisions, not just the what. It's typically a short paragraph that outlines the decision itself, what problem it solves or opportunity it addresses, the options you considered, and why you chose one over others, along with any potential impacts. They help build documentation and provide traceability throughout your architecture's evolution. Okay, let's talk about how to make your architecture documentation really effective. The first thing is clarity. Aim for simple, easy to understand language. Think about who you're writing for. A CEO will want different information than a developer. Organization is super important too. Use headings and tables to break things down. Don't forget visuals. Diagrams can really help people grasp complex ideas. And, crucially, keep your documentation up to date with version controls so everyone knows what the current state of the architecture actually is. Okay, let's talk about how digital transformation connects with our architecture frameworks. Think of it this way: digital transformation isn't just buying new software. It's a whole shift in how we do things. TOGAF and Zachman provide the blueprints to navigate that complexity. TOGAF gives us a structured, phased approach, like building a house step by step, making sure everything aligns with what the business needs. Zachman, on the other hand, helps us see the bigger picture, considering all aspects of our organization: data, processes, and people, to understand where we stand and where we need to improve. Enterprise architecture is the key player here, acting as a translator between these frameworks and the actual transformation projects, ensuring that everything moves in the right direction. Okay, let's talk about building enterprise architectures specifically with cloud in mind. We start with well-established frameworks like TOGAF and Zachman. They give us a solid foundation of structure and views. But the cloud throws a few curveballs. For example, we're often using microservices now, breaking down applications into smaller, independent pieces that can scale really well. And because everything is automated these days, infrastructure as code tools like Terraform are critical for managing our infrastructure consistently and reliably. Finally, understanding the different cloud service models IaaS, PaaS, and SaaS helps us build the right architecture for each piece of our business. Okay, let's talk about business capabilities. They are absolutely vital when we're looking at enterprise architecture. Think of them as the core things your organization does to deliver value, like managing customer relationships or developing new product. They are not just about the individual processes involved. It's what you're doing overall. We can see a simple example: customer relationship management would involve activities like lead generation and customer service. Business capabilities help us align our IT investments with our broader strategic goals, whether we're using TOGAF or Zachman's framework. Okay, let's talk about how we measure the success of our IT architecture. It's not enough just to have pretty diagrams. We need to understand if these architectural changes are actually delivering value for the business. We break down measurement into key categories, things like reducing costs, boosting efficiency, minimizing risk, and even driving innovation. You'll see a table showing some example KPI with targets that illustrate what success looks like. Think about using the SMART framework, making sure your goals are specific and clearly defined to help you track progress effectively. Okay, let's talk about EA operating models. Think of these as the blueprints for how your enterprise architecture team actually works. They aren't just about creating diagrams. They define who does what, how decisions are made, and the processes you use to build and maintain your IT architecture. It's all about governance, making sure everyone understands their roles and responsibilities. We look at defining clear roles like chief architect or solution architect, standardizing processes for everything from gathering requirements to managing changes, and even selecting the right tools to help the team do its job effectively. Ultimately, a solid EA operating model helps you align your architecture with what's important for the business, driving investment that actually delivers value. Okay, let's talk about bringing agile thinking into enterprise architecture. We've all seen traditional frameworks like TOGAF and Zachman. They can be really helpful as a starting point. But the key is to adapt them. Think of it like this: instead of trying to follow every step exactly, we embrace iterative cycles, much like in agile sprints. Collaboration between architects, developers, and business stakeholders is absolutely crucial. Architecture shouldn't happen in isolation. And most importantly, let's focus on delivering value quickly. Prioritize architectural investments based on what will give you the biggest impact, just like an MVP for software. Finally, constantly get feedback from your teams and users to ensure your architecture decisions are still aligned with their needs. Let's talk about bringing DevOps and enterprise architecture together. Think of TOGAF as a roadmap for building your overall architecture. It gives you a structured way to plan, design, and implement changes. Zachman's model helps you understand the different perspectives needed to see the whole picture, from data all the way up to technology and time. Now, DevOps is all about getting things done quickly and efficiently through automation and collaboration. The magic happens when these two approaches work hand in hand. EA focuses on what we need to build, while DevOps figures out how we're going to get it there. It's not a replacement of one over the other. Instead, focusing on value streams helps us align our efforts and track what really matters. We can use metrics like deployment frequency and lead time to measure both architectural health and operational speed. Okay, let's talk about how these architecture frameworks can really help during a merger or acquisition. It's a complex situation because you're essentially combining two separate worlds of IT, and that can lead to huge challenges if not handled strategically. TOGAF provides a really useful phased approach. Think of it like a roadmap for building an enterprise architecture, while the Zachman framework helps you understand everything involved, all the people, processes, technologies, and data by looking at it from different angles. During M&A, we need to start with a clear assessment of both companies' existing architectures, then align on common goals and principles. Finally, we create an integration roadmap that covers timelines, resources, and potential snags, and then put in place governance to keep things running smoothly. Okay, let's talk about building a data-driven enterprise. We're looking at how TOGAF and Zachman can help us do that effectively. TOGAF gives us a strategic roadmap for IT architecture, making sure it aligns with the business goals. Zachman provides a really broad view of everything involved in an organization, from data itself to processes and people. The key here is moving beyond just collecting data. We need to actually use it for insights and smarter decisions. Think about how TOGAF's ADM process, combined with Zachman's dimensional model, allows us to build a solid architecture around our data, ensuring it's governed, secure, and ready for analytics. Okay, so we're now diving into how artificial intelligence is changing the game when it comes to enterprise architecture. Traditionally, things like TOGAF and Zachman provide a really solid foundation or framework for planning your IT landscape. But AI isn't just about automating some tasks, it fundamentally changes how architectures are built and managed. We're talking about systems that can actually adapt in real time to new data and changing business demands, rather than being fixed blueprints. AI is also driving massive automation. Think of how much faster architecture design and implementation can be when you're relying on intelligent tools to guide the process. And perhaps most excitingly, AI-powered architecture tools offer intelligent recommendations suggesting the best ways to allocate resources, improve security, or even optimize integration patterns. It's all about moving from a static plan to a dynamic, responsive ecosystem. Let's talk about getting IT in your business talking the same language. It's not enough for IT to just build systems, they need to be directly supporting your goals. We've got a few key strategies we can use. First, establishing a shared vocabulary. Everyone needs to understand terms like customer experience using the same definitions. Second, mapping out those business capabilities. How are our IT services actually helping us achieve what we set out to do? Third, managing the IT portfolio. Are you investing in the right things that deliver real value? And crucially, building strong relationships between IT and your business stakeholders through open communication and collaboration. Okay, let's talk about getting everyone on board with your IT architecture plans. Communication is absolutely critical here. First, you need to figure out who needs to know what. Map out all the stakeholders, from the top executives who want to see strategic alignment, all the way down to the IT teams who will be building and maintaining the system. Then, don't just send a generic email, create tailored communication plans for each group. A CEO might need a high-level summary, while developers need detailed technical specifications. Keep them updated regularly with progress reports, and most importantly, ask for their feedback. Being transparent about the reasons behind your architectural choices builds trust, and having a plan to resolve conflicts when opinions differ ensures smoother implementation. Okay, let's start at the very beginning with understanding why we're designing IT systems in the first place. The most important thing to remember is that architecture isn't just about technology, it's all about aligning your systems with what the business needs. We need to really dig into those strategic goals and identify exactly what the organization wants to achieve, then translate those goals into specific requirements. It's about scoping the project clearly, knowing exactly what's in and out of scope to keep things manageable. Let's talk about the System Development Lifecycle, or SDLC. It's a really important concept when we're looking at architecture methodologies. Think of it as a blueprint for building software, step by step. There are several different models out there, like Waterfall, which is a pretty classic, linear approach where you move through each phase in order. Then there's Agile, really popular these days, that focuses on shorter cycles and constant feedback. And finally, Spiral, which is great for projects where you need to manage risk effectively. Each one has its strengths and weaknesses, so choosing the right SDLC model depends heavily on your project's specific needs. Okay, let's talk about how Agile fits into the bigger picture of IT architecture. Think of Agile as a really fast-paced way to build software. It's all about short cycles and constant feedback. We start with high-level needs, then break them down into smaller user stories, plan what we want to achieve in each sprint, usually 2 weeks, actually build and test the features, show it off to stakeholders for their input, and finally, reflect on how things went so we can improve next time. It's a very iterative process. Now, frameworks like TOGAF and Zachman are helpful because they provide a structured approach to understanding what architecture you're building and how to view it from different perspectives. Agile helps make those structures more adaptable to changing needs. Okay, so after we've got a general idea of what the business wants to achieve, like with our strategic alignment, this step is all about getting super specific. We need to understand exactly what asterisk needs to be built and how it should work. TOGAF emphasizes really digging into those business requirements, talking to stakeholders, and documenting everything thoroughly. Zachman's approach reminds us that we need to consider different perspectives when gathering these requirements to what the data looks like from a user's point of view. We use techniques like interviews and brainstorming, document our findings with things like user stories, and then prioritize them using methods like MOSCOW to make sure we're focusing on the most important stuff. Finally, it's crucial to validate those requirements with stakeholders to actually confirm they've captured what everyone needs. Okay, let's talk about the foundation of any good system: requirements. We're going to look at functional and non-functional ones. Think of functional requirements as all the specific things a system needs to do, like logging in or processing payments. They define what it does. But then there are non-functional requirements, which aren't about doing something, but how well it's done. These are about qualities like speed, security, and ease of use. It's crucial to consider both when designing your IT architecture. Let's break down the differences a little further with the simple table. Okay, let's talk about how we actually analyze systems, what we do to figure out how things work now and how they could be even better. We have a few key frameworks that help us with this. TOGAF is a big one. It's a complete architecture framework that guides you through building an enterprise architecture in stages. Then there's the Zachman framework, which helps you look at systems from 6 different angles: data, models, networks, processes, people, and time. And BPMN, well, that's a visual way to map out business processes, showing all the steps involved. These aren't competing approaches. Often organizations combine pieces of them for the best fit. Okay, let's talk about how we can actually apply these architecture frameworks. We've got TOGAF and Zachman. They're big blueprints for IT, but sometimes it feels a little abstract. So, to make them more concrete, we're going to look at modeling techniques like use cases and user stories. Use cases help us to find what a user is trying to do with the system. We identify who's interacting, what they're trying to achieve, and then we map out the steps involved. Then there are user stories. These focus on the why. They really capture the value from the user's perspective. Think of them as simple statements like, as a customer, I want to track my order status so that I know when it'll arrive. They are a fantastic way to prioritize development and ensure you're building features that truly matter. Ready to dive deeper into TOGAF and Zachman? Let's talk about business process modeling, or BPM. Essentially, it's all about visually mapping out how things actually get done within an organization, step-by-step processes that drive our work. Now, why is this important for understanding TOGAF and Zachman? Well, BPM gives us tangible data to really ground those frameworks in reality. TOGAF's architecture design phases benefit hugely from a clear picture of how processes operate. And Zachman's 5 views become much more meaningful when you can connect them directly to specific business activities. We often use tools like BPMN or simple flowcharts and swimlane diagrams to really illustrate the process steps involved. Think of it as building a roadmap for execution, ensuring that our architecture supports the way we actually work. Okay, let's talk about business process reengineering. Think of BPR as a really big reset button for how your organization operates. It's not just tweaking things a little, it's about completely rethinking the core processes, how work actually gets done. The key is to start with what you want to achieve, like increased efficiency or better customer satisfaction, and then design processes from scratch that will get you there. We look at current workflows, identify major problems, and create entirely new models, often using technology to make them happen. This aligns perfectly with the strategic planning phase of TOGAF. BPR gives you a strong foundation for building an IT architecture that supports those big picture goals. Okay, let's start with the foundational piece, information systems architecture. This is really important because it's about how all the pieces, your people, processes, data, and technology fit together to support what you're trying to achieve as an organization. It's like creating a blueprint for your entire IT landscape, ensuring everything works in sync and efficiently. We'll break down the key components, business processes, how data is handled, the applications you use, and the underlying infrastructure that makes it all run. Okay, so let's talk about how data architecture fits into the bigger picture of TOGAF and Zachman. These methodologies provide a lot of guidance, but you really need to understand some core principles first. We're talking about things like establishing clear ownership over your data, who's responsible for what, ensuring that the information you're using is actually accurate and reliable, which is where data quality comes in. And crucially, remember that security and privacy are paramount these days, so think about how you're protecting sensitive information. Okay, let's talk about how we model data for IT architecture. We've got a few different techniques to choose from. First up is entity relationship diagrams. These are really great for getting a visual overview of your data and understanding how everything connects. Then there's dimensional modeling, popularized by Kimball, which focuses on business processes and measuring things effectively, often used when building data warehouses. Document-oriented modeling is pretty flexible and good for smaller projects where you might just use spreadsheets or documents to map out the structure. And finally, we have graph databases. These are fantastic for representing relationships as nodes and edges, making them perfect for things like social networks or recommendation systems. Okay, let's talk about data warehousing. It's a really important piece of the puzzle when we're thinking about overall IT architecture. Basically, a data warehouse is like a super organized central hub where information from all your different systems, things like your customer relationship management software and your financial records, gets combined and cleaned up. We use something called ETL to get that done, extracting the raw data, transforming it into a consistent format, and then loading it into this warehouse. This structured data is then ready for business intelligence tools, allowing people to analyze trends and make smarter decisions. It's not just about collecting more information, it's about ensuring you have reliable, usable data at your fingertips. Okay, let's talk about data governance frameworks. They're really crucial for any organization that wants to be smart about its data. Essentially, it's a set of guidelines or rules of the road, if you will, dictating how we manage, use and protect our information. It covers things like clear policies on what we should do with data, standards for making sure everything is consistent, think standardized naming conventions, and most importantly, clearly defined roles and responsibilities so everyone knows who's accountable for data quality and security. Importantly, these frameworks fit neatly into the TOGAF architecture process, especially during design, and align with Zachman's perspectives, ensuring a holistic view of our IT landscape. Okay, let's talk about master data management, or MDM. Think of it as the bedrock for reliable data across your whole organization. It's not just about collecting lots of information, it's about making sure you have *1 definitive version of critical facts like customer details, product information, or vendor contacts. MDM builds upon the principles outlined in TOGAF and Zachman's frameworks, ensuring that data governance and quality are baked into the architecture from the start. Essentially, MDM tackles the challenge of inconsistent data scattered across different systems, providing a single source of truth to drive better decision-making. It's a really crucial piece for any modern IT strategy. Okay, so when we're looking at application architecture, we need a solid foundation. TOGAF's architecture development method is all about taking an iterative approach, starting with a clear vision and building from there. It uses something called the application component landscape to map your applications back to what they actually do for the business. Now, Zachman's framework provides a really helpful way to think about this landscape. It breaks down different views of your application, things like data, hardware, people, each offering a unique perspective. The cool thing is TOGAF and Zachman are mutually exclusive. You can use them together to get a really complete understanding of how everything fits together. Okay, let's talk about some really important design principles when building applications. First, we want to think about modularity, breaking big, complicated apps down into smaller, easier to manage pieces. This makes things way simpler to maintain and reuse later on. Next, loose coupling is key. You don't want your components to be overly dependent on each other. Changes in one part shouldn't break everything else. High cohesion means each component should really focus on doing just one thing well. Abstraction hides the complexities of how something works, so users and developers can focus on what does. And finally, separation of concerns, dividing your application into distinct areas like presentation, business logic, and data access. It's all about creating a flexible and manageable system. Okay, let's talk about application portfolio management, or APM. It's really important when you're looking at architecture frameworks like TOGAF and Zachman. APM is all about understanding what applications you have, why you have them, and how to manage them strategically. It's like creating a super detailed inventory of everything, but it goes beyond just listing apps. It's about figuring out if they are still serving their purpose and aligning with the company's goals. We look at things like classifying applications based on their value and cost, then analyze the portfolio to spot opportunities for streamlining or even retiring older systems. Basically, APM brings TOGAF and Zachman together into a really useful strategy for managing your IT assets. Okay, let's talk about how we actually bring all these architectures together, specifically application integration. TOGAF encourages us to look at common integration patterns, like making systems talk to each other through events or notifications. Zachman's framework is really helpful here too. It helps you understand the different ways you can view an application from various angles, what's logical, what's physical. It gives a good holistic picture. And today, with API-led connectivity and microservices becoming more popular, we're using API as the primary way to connect our applications. Remember that security, data consistency, and monitoring are all hugely important aspects to consider when designing how these systems will work together. Let's talk about API-led integration. It's a really smart way to approach how different systems in an organization communicate. Traditionally, we built integrations directly between applications, which quickly became a tangled mess. With API-led integration, we shift our focus to designing individual business capabilities as reusable API. Think of it like building with Lego bricks. You connect them together to create something bigger and more complex. This approach creates loose connections, so changes in one system don't automatically break everything else, and it allows us to reuse those API across the entire organization, speeding up development and reducing costs. Okay, let's talk about API management platforms and how they fit into the bigger picture of IT architecture. We've been looking at frameworks like TOGAF and Zachman to get a structured approach, and API management is becoming a really important part of that. Think of an API management platform as a central hub for all your API. It handles things like security, routing requests, and providing analytics. These platforms align with the different perspectives in Zachman's model, ensuring you're covering everything from technology to people and processes. And because TOGAF emphasizes managing the entire life cycle of architecture components, API management platforms are a critical element in that process too. Essentially, they help you build more secure, efficient, and adaptable systems. Let's talk about service-oriented architecture, or SOA. Think of it like building with Lego bricks. Each brick is a service, and they connect in ways that are independent and reusable. Instead of having one big, monolithic application, you break things down into smaller, self-contained services that communicate with each other using standard methods. This creates much more flexibility, allows different teams to work on parts independently, and makes it easier to adapt to changing business needs. Okay, let's dive into microservices architecture. It's a big shift from traditional monolithic apps. Think of it like breaking down a huge building into smaller, independent units. Each unit, or microservice, handles a specific business capability, making the system more adaptable and easier to scale. These services are small-focused, and generally operate independently, giving teams more control. They're built with different technologies if that's what makes sense for the job, and they talk to each other through well-defined API. It's a design approach prioritizing flexibility and resilience, things we really want in today's IT landscape. Okay, let's talk about event-driven architecture, or EDA. Think of it as a way to build systems that are much more responsive and adaptable. Instead of programs constantly talking asterisk to asterisk each other, they react asterisk when asterisk something happens in an event. It's like a chain reaction. You have producers that create these events, consumers that listen for them, and a central broker, often a message queue, to make sure everything gets where it needs to go. EDA fits in really well with both TOGAF and Zachman. TOGAF's ADM can be adjusted as you design, making sure you're thinking about how events drive your architecture. And Zachman's framework helps you document all the different parts of the system and how they interact when things are happening. Okay, let's talk about ZQRS. It's a really clever way to approach database design, especially when you have a lot of data being read and written all the time. Basically, it separates the operations into two distinct approaches: commands and queries. Commands are like actions: creating something, updating something, deleting something. They change the state of the system. Queries, on the other hand, are just for reading information. They don't actually modify anything. Think of it this way: if you're adding a new product to an online store, command, that's different from simply displaying the product details in your shopping cart, a query. ZQRS allows us to optimize each of these types of operations, leading to much better performance and scalability. Okay, let's talk about event sourcing. It's a really clever technique that can be incredibly useful when you're designing an architecture, especially with frameworks like TOGAF and Zachman's. Instead of just keeping track of where things asterisk are asterisk, we focus on what asterisk happened asterisk. We record every single change as an event, creating an immutable log of everything that's changed over time. Think of it like a detailed history book for your data. It allows us to easily audit transactions, figure out exactly why something happened, and even recreate past states, which is super valuable for debugging and building flexible systems. Okay, let's talk about designing distributed systems, a really important area when we're considering these architecture frameworks. We need to think about how components within our system can work independently and still deliver value. Key concepts include loose coupling, meaning minimizing dependencies between services, asynchronous communication to handle loads effectively, and building in fault tolerance for resilience. Scalability is also crucial, making sure the system can grow as demand increases. And, of course, data consistency needs careful consideration using models like eventual consistency. TOGAF and Zachman are great tools here. Zachman helps us define what architectural views we need, while TOGAF provides a structured approach to getting there. Okay, let's talk about middleware and message brokers. Think of these as the glue that holds your IT ecosystem together. From an architectural standpoint, TOGAF sees them fitting within the application layer. They're all about connecting different parts of your business systems. Zachman's framework helps us understand how they fit into a broader view, particularly regarding implementation and data flows. Message brokers like Kafka or RabbitMQ handle asynchronous communication, so apps don't have to wait for each other. Middleware platforms then take it a step further, offering things like service orchestration and API management. Essentially, these technologies are vital for creating flexible and scalable systems. Okay, let's talk about scaling your IT systems. It's not just about making things asterisk faster asterisk today. It's about ensuring they can handle growth and changing demands in the future. We've got two big frameworks to consider, TOGAF and Zachman, but for this slide, we're specifically looking at how to design for scalability. Basically, you need to think about whether you'll be adding more machines, horizontal scaling, or beefing up existing ones, vertical scaling. Cloud services offer incredible flexibility with auto-scaling capabilities. And the modern approach, like microservices architecture, allows individual parts of your application to scale independently, really powerful. Remember, TOGAF helps you create the overall roadmap, and Zachman gives you a holistic view of all the different aspects of your IT. Okay, let's talk about keeping our systems running smoothly, even if things don't go as planned. We're looking at high availability and fault tolerance, essentially how we build resilience into our IT architecture. Think of it like having backup plans for backup plans. High availability is about aiming for near constant uptime, while fault tolerance is the ability to handle failures without major interruptions. We'll explore some key strategies like clustering with load balancing, replicating data across multiple sites, and automating those failover processes so our systems can bounce back quickly. Okay, let's talk about making systems run faster and smoother. When we're optimizing performance, it's really useful to have a good architectural approach. Methodologies like TOGAF and Zachman give us the what needs to be optimized, but techniques like code profiling and database tuning are where things get specific. We can use profiling tools to find exactly where slowdowns occur in our code. Database tuning is vital, ensuring queries run efficiently and indexes are properly set up. Caching helps reduce load on servers by storing frequently accessed data. Finally, load balancing distributes the workload across multiple servers, preventing any single server from being overwhelmed. Okay, let's talk about how we think about infrastructure within these architecture models. Both TOGAF and Zachman provide a way to organize our IT systems, but they look at it from slightly different angles. TOGAF is like a whole picture roadmap. It's all about aligning your business goals with how your technology supports them. It's a process for building an architecture step by step. Zachman, on the other hand, is more of a detailed blueprint. It's a way to describe what information you need to understand the architecture at different levels, from high-level business goals down to specific hardware components. Infrastructure itself, things like servers and networks, is a key part of both, but TOGAF focuses on how it fits into the bigger picture of your overall enterprise architecture, while Zachman breaks it down into its various facets. Okay, let's talk about where our IT systems live. Traditionally, most companies build their infrastructure servers, networks right inside their own buildings, creating what we call on-premise environments. This gave them a lot of control, but also meant they were responsible for everything from hardware upgrades to software patches, which could be really time-consuming and expensive. Now, cloud-native architecture is changing the game. It's about designing applications specifically to work well in the cloud. Think smaller, independent pieces called microservices, packaged up in containers and managed by powerful orchestration tools like Kubernetes. This approach makes scaling much easier, often shifting costs from large upfront investments like buying servers to ongoing operational expenses. Okay, let's talk about how we approach cloud architecture. We want systems that can grow with us, so scalability is key. Then, building in resilience and availability makes sure things don't go down unexpectedly. Cost optimization is a big one too. The cloud offers amazing ways to save money if you design smartly. And of course, security needs to be baked in from the start. Finally, we need to be able to see everything going on. Monitoring and logging are essential. Thinking about these principles through the lens of TOGAF and Zachman's framework ensures your cloud architecture is built for long-term strategic success. Okay, let's dive into how we design applications that really thrive in the cloud. We're talking about cloud native, and it's all about building software that's incredibly flexible, can handle massive changes, and keeps running reliably. A core strategy is microservices. Think of breaking down a large application into smaller, self-contained units that work together. Then you wrap them up in containers like Docker, making sure they behave the same way everywhere. Automation through DevOps and CI/CD pipelines speeds up development while treating your infrastructure as code. Essentially, building it with software helps ensure everything stays consistent and manageable. It's a shift toward agility and responsiveness. Okay, so let's talk about moving your systems to the cloud. It's more than just signing up for a service. There are several different ways you can do this, each with its own pros and cons. We'll look at some common strategies. Rehost, which is basically moving things as they are. Replatform, where you tweak your applications to work better in the cloud. Refactor, which involves a more significant redesign. And replace, where you build entirely new solutions from scratch. Each of these approaches aligns with different stages of development, mirroring how TOGAF's architecture methodology looks at an organization's current state versus its desired future. Okay, let's talk about designing for multi-cloud and hybrid environments. As businesses grow, relying on just one cloud provider can become limiting. We need to think strategically. How do we use the strengths of different clouds while maintaining control? TOGAF and Zachman provide frameworks that help us understand our business capabilities and technology dependencies across these diverse environments. Think about aligning your overall IT strategy with cloud choices. We'll look at common patterns like active-active setups for maximum availability or a more traditional active-passive model. The key is to choose the right architecture based on your specific needs and goals. Okay, let's talk about infrastructure as code or IC. Think of it as bringing TOGAF and Zachman into the practical world of building IT infrastructure. Instead of manually configuring servers and networks, we define our desired environment using code, usually with tools like Terraform or Ansible. We're basically telling the system what we want, not how to get there. This is a declarative approach. It's all about describing the final state. We also track this code in version control systems like Git, which means we can easily roll back changes if needed. And because IC tools are designed to be idempotent, running the same code multiple times will always produce the same result. A quick example shows how Terraform defines a basic AWS instance. It's about taking these high-level architectural concepts, TOGAF and Zachman, and using IC as the way to actually build them out. So, you'll want to explore different IC tools and figure out which ones best fit your organization's needs. Let's talk about how virtualization and hypervisors fit into our architectural thinking. These technologies are fundamentally changing how we approach IT infrastructure. TOGAF, with its emphasis on iterative development and aligning architecture with business capabilities, really benefits from the flexibility of virtualized environments. You can quickly spin up resources as needed, a huge win for agile projects. Zachman's framework also takes notice. Data virtualization allows us to think about data in terms of logical access points rather than physical locations, which is crucial for understanding and managing complex data relationships. Okay, let's talk about containerization. It's a really big shift in how we think about deploying applications. Instead of needing to run an entire virtual machine for each app, containerization uses something called images and containers. Think of an image like a blueprint. It contains everything the application needs to run code, libraries, dependencies. Containers are then created from those images, essentially running instances of that blueprint. Docker is probably the most well-known platform for this, but Podman is another excellent option, especially if security and simplicity are top priorities. Containerization leads to faster deployments, better use of resources, and makes your applications more portable across different environments. It's a game changer for modern IT architecture. Let's talk about Kubernetes. It's a really important part of modern IT architecture. Think of it as an automated conductor for your containerized apps. You package everything you need into containers, and then Kubernetes manages them, ensuring they run smoothly, scale up when needed, and recover automatically if something goes wrong. It builds on the ideas from methodologies like TOGAF and Zachman by giving you a structured way to manage this complexity. Essentially, it's about automating the deployment and management of applications across your infrastructure, making things much more efficient and resilient. Okay, let's talk about serverless architecture. It's a really popular trend right now, and it can seem a little confusing at first. The key thing to remember is that serverless doesn't mean there are no servers involved. It just means you don't have to manage them. Instead, you're leveraging cloud providers like AWS, Azure, or Google Cloud to handle the underlying infrastructure. We've got function as a service, where you write small pieces of code that respond to events. Backend as a service, which gives you ready-made backends, things like user authentication and databases, and an event-driven approach, meaning your functions are triggered automatically when something happens. It's all about scaling up or down on demand, paying only for what you use, and freeing developers from server management tasks. Okay, let's talk about edge computing architecture. Basically, instead of sending your data back to the cloud for processing, we're starting to do some of that work right where it happens closer to the devices or sensors creating the data. This dramatically cuts down on lag, which is super important for things like self-driving cars or industrial automation. It also reduces how much data needs to be sent over networks, saving bandwidth and money. Think about factories with lots of sensors or augmented reality apps. These are prime examples where edge computing really shines. And when you're designing an architecture for something like this, it's really important to consider how it fits in alongside established frameworks like TOGAF and Zachman. Okay, let's talk about network architecture design within the bigger picture of IT architecture. When we're mapping out a network, it's really important to think about how TOGAF and Zachman can help us. TOGAF gives us a structured approach to development, a roadmap if you will, and Zachman's framework provides this critical data model that helps us understand all the different components of our systems and their connections. We need to consider things like network segmentation, creating logical boundaries for security and efficiency. Then look at modern technologies like SD-WAN, which can dramatically improve performance. Don't forget about cloud connectivity. Secure links are vital. And of course, a strong security architecture is non-negotiable. It's all about balancing business needs with resilience and using those architectural frameworks as guides. Okay, let's talk about load balancing. It's a really important concept in modern IT architecture. Basically, instead of having one single server handle all the traffic, a load balancer distributes that traffic across multiple servers. This makes things much more efficient and reliable. If one server goes down, others can pick up the slack. We'll look at some different types of load balancers, from dedicated hardware devices to software solutions like Nginx or HA proxy. And then we'll dive into how they actually decide which server gets each request. There are several algorithms involved, things like round robin, where requests go to servers in order, or least connections, sending traffic to the server with the fewest active connections. Okay, let's talk about firewalls and security zoning. Both TOGAF and Zachman recognize that strong security is absolutely crucial in any IT architecture. Think of TOGAF as guiding you to build an architecture that really supports your business goals, and a secure network is definitely a key part of that. Zachman's framework looks at things from all angles, and firewalls and zoning are very relevant when considering the technology perspective. Essentially, a firewall is like a gatekeeper, examining every piece of traffic coming in and out of your network based on rules you set. And security zoning divides your network into different areas with varying levels of protection. It's about limiting damage if one part gets compromised. We'll cover things like firewall rules, DMZs, and even VLANs to give you a better understanding of how these concepts work together. Okay, let's talk about disaster recovery planning. This is a really important part of building a resilient IT architecture, fitting right in with frameworks like TOGAF and Zachman's model. Basically, we're talking about how to keep the business running if something bad happens, whether it's a power outage, a cyber attack, or some other kind of disruption. We need to think about what could go wrong and how quickly we can get back up and running. It's about setting clear goals for recovery time and acceptable data loss. Thinking about these things within the context of TOGAF and Zachman's frameworks ensures that DR is planned as part of a larger, strategic process. Okay, let's talk about business continuity architecture. Think of it as your organization's plan B. It's a critical part of IT architecture, but it zooms in specifically on how we keep the business running if something unexpected happens, a natural disaster, cyber attack, or even just a major system failure. We use frameworks like TOGAF to build a repeatable process for this. We start by identifying what's most important to our business, those key functions. Then we map out all the connections between systems and processes. Next, we figure out what could potentially disrupt things and assess the risks involved. Finally, we design recovery strategies, everything from regular backups to having backup sites or leveraging cloud-based solutions. And of course, it's not enough just to have a plan. We need to test it regularly to make sure it actually works. Okay, let's talk about monitoring and observability. It's a really crucial piece of modern IT architecture. We're going beyond just knowing if things are running, like checking CPU usage or memory. Instead, we're aiming for observability, which means understanding the why behind issues. This involves gathering 3 key types of data. Metrics, those are your numbers that show trends, logs detailed records of what's happened, and traces their like following a request as it travels through your entire system to help find exactly where problems are occurring. Okay, let's talk about logging and audit trails, a really important part of maintaining control over your IT architecture. Think of it like this. We need to know what asterisk is changing in our systems and who made the change. TOGAF helps us define what exactly we should be tracking, ensuring we have clear goals for these audits. Zachman's framework can then help us map those logs back to specific components within the architecture, giving us even greater traceability. In practice, this means setting up centralized logging systems. Tools like ELK or Splunk are great for gathering all that data. And, of course, security is key. We need to protect sensitive log information with strong access controls and encryption. Okay, let's talk about data privacy and protection architecture. This is a really important area to consider when designing your IT systems. We're building on our understanding of TOGAF's iterative process, using it as a foundation for this specific focus. Key things we need to think about are gathering detailed requirements like GDPR or CCPA and then identifying the architectural components that will help us meet those needs. This could include techniques like data masking, anonymization, and encryption. It's also vital to understand how all of this fits into your broader IT architecture, ensuring it integrates seamlessly with applications and infrastructure. From a Zachman perspective, we're looking at a data view, essentially documenting what information you have, how it's used, and its relationships. Finally, remember that data privacy is an ongoing process. Continuous monitoring and adaptation are essential as regulations change. Okay, let's dive into how TOGAF and Zachman frameworks can help us think about identity and access management. TOGAF's approach is all about building architecture in stages, and IAM fits right in during the implementation phase. Think of it as making sure everyone has the right keys to the right doors. Zachman provides a really helpful map of how we should be looking at our IT systems from different angles: data, people, technology, etc. And IAM is key to managing identities, roles, and permissions across all these viewpoints. Essentially, they both help us ensure secure access while maintaining compliance with policies. Let's talk about how we're building IT architectures today. We've got three big players: TOGAF, which is all about connecting your IT strategy with your business goals; Zachman, which gives us a really detailed look at everything data, models, even the people involved in our systems. And then there's Zero Trust Security. Think of it like this: instead of trusting anyone just because they're inside the network, we treat everyone as potentially risky and constantly verify their identity and access rights. We can see how integrating these approaches provides a much more secure and flexible foundation for your technology. Okay, let's talk about how security fits into our overall IT architecture. We're looking at cybersecurity through the lens of TOGAF and Zachman. These frameworks give us a great starting point for structuring our thinking, but it's crucial to remember that security isn't just an add-on. We need to build in core principles like confidentiality, protecting sensitive data integrity, ensuring data stays accurate, availability, guaranteeing systems are always online, authentication, verifying who's accessing what, and non-repudiation, proving actions were taken. These aren't isolated concepts. They have to be considered from the very beginning of any architectural design process, alongside things like compliance with regulations like GDPR or NIST standards. Any questions so far? Okay, let's talk about threat modeling. It's a really important step in building secure and reliable systems. Basically, it's like a detective exercise for your IT architecture. We start by figuring out what we need to protect our assets, which could be anything from sensitive data to critical servers. Then, we brainstorm all the possible ways those assets might get harmed, things like malware attacks or even just people trying to trick employees. We analyze how easy each of these threats would be to execute and then prioritize them based on their potential impact. It's a way to proactively spot risks before they cause damage, and it ties in really well with the broader frameworks we've been discussing like TOGAF and Zachman, helping us understand the context and scope of our systems. Okay, let's talk about how we can build a strong security architecture. Both TOGAF and Zachman are valuable frameworks for thinking about IT. TOGAF helps us understand how to design our systems, while Zachman focuses on what those systems actually covering everything from data to people. We'll look at some key security patterns like data masking, encryption, least privilege access, and defense in depth. These aren't just random ideas, they can be strategically placed within either of these frameworks, linking specific security measures to particular parts of the architecture. It's about creating a layer approach, multiple safeguards working together for maximum protection. Okay, let's talk about building big data systems. These architectures are all about handling massive amounts of information, think terabytes, even petabytes. We need to consider the sheer volume and speed at which this data is coming in, along with the different types of sources it's coming from. It's not just numbers, we're dealing with text, images, and everything in between. TOGAF helps us keep these systems aligned with our overall business goals, while Zachman's framework gives us a really broad view, thinking about all the different angles of what data means and how it should be used. Essentially, ensuring everyone is on the same page. Okay, so we're moving beyond the broad strokes of TOGAF and Zachman. Let's talk about Lambda and Kappa architectures. They help us tackle modern IT challenges more effectively. Think of Lambda as a layered approach. It combines your strategic business goals with the core IT systems that support them, and how those processes are executed. It's great for maintaining existing investments while adding some speed. Now, Kappa takes things even further. It's an event-driven architecture built on top of Lambda, meaning changes trigger actions automatically rather than relying on rigid sequences. It uses technologies like Kafka to handle streams of data in real time and breaks things down into smaller, independent microservices, making it super flexible for rapid innovation and continuous change. Essentially, if you need constant experimentation and quick delivery, Kappa is your friend. Let's talk about designing systems that need to react instantly like real-time fraud detection. To build a scalable and reliable architecture for this, we'll use TOGAF and Zachman as our guiding lights. TOGAF helps us structure the whole process, from understanding what the business needs all the way through building and maintaining the system. Think of it like a roadmap. Zachman's framework is equally important. It reminds us to consider everyone involved, not just the tech specs, but also the people who use the data and the rules that govern it. We need to prioritize low latency, meaning super fast response times, and ensure our system can handle spikes in activity. Technologies like Kafka or Flink are key. Essentially, we're creating an event-driven architecture where different parts of the system talk to each other without being tightly coupled. Let's talk about how data lakes and data warehouses differ. A traditional data warehouse is like a really well-organized library. Everything has its place and you know exactly where to find it if you have a specific question in mind. It's built for structured reporting and analytics. Now, a data lake is more like an archive. It holds the data, regardless of format or structure, ready for exploration. You don't need to define how it's used upfront. That happens as you start digging through it. Okay, so this slide focuses on building systems for artificial intelligence and machine learning. These aren't just about the algorithms themselves, it's about how everything around them is designed. We need to think carefully about our data, making sure it's good quality and in enough quantities. Then we have to architect the process of building, testing, and actually deploying those models. It's not as simple as just writing some code. Scalability becomes a huge consideration. AI/ML often needs serious computing power. And let's not forget about fairness. We need to understand why a model is making certain decisions and actively work to prevent bias. TOGAF helps us keep the big picture in mind, while Zachman gives us a really detailed view of what data we need. Okay, let's dive into designing EOT systems. We're going to use a combination of frameworks TOGAF, Zachman, and some modern architectural patterns to build something truly effective. Think about it like this: TOGAF gives us a roadmap for the whole enterprise architecture, ensuring everything aligns with business objectives. The Zachman framework helps us consider aspects data, processes, people, and technology to avoid overlooking critical details. And we'll leverage modern patterns like microservices and event-driven architectures to make our IoT systems scalable, flexible, and resilient because, let's face it, IoT devices are constantly generating a huge amount of data that needs to be handled effectively. Okay, let's dive into designing a blockchain system. We'll be using frameworks like TOGAF and Zachman to really think through the architecture from multiple angles. TOGAF helps us structure our approach with phases. We start by defining what we want to achieve and then work systematically towards implementation. The Zachman framework is crucial here too. It forces us to consider all aspects of IT, from data and functions to hardware and people, ensuring a holistic view. Specifically, when building a blockchain, we need to think about things like the platform we'll use, how our data will be structured using smart contracts, security measures, and governance, all elements that can be mapped against Zachman's dimensions. Let's break down some key design steps, starting with defining the business goals and then selecting a blockchain platform, followed by designing the data structure and building those essential smart contracts. Okay, let's talk about how API gateways and service meshes fit into the picture. Think of an API gateway as your front door for all incoming requests. It handles things like authentication, routing those requests to the right services, and even transforming data along the way. It's a central point of control for external users. Now a service mesh is more like a backstage crew managing how the internal services talk to each other. It's an infrastructure layer that automatically handles traffic, provides resilience through things like circuit breakers, and enforces security policies between those services. They are different but complementary. The gateway deals with what goes asterisk at asterisk, while the mesh manages what's happening asterisk within asterisk your application. Let's talk about something really important for keeping your data safe: network segmentation. Think of it like building walls around different parts of your business: marketing, finance, development. Each needs its own space and level of protection. We're not just talking about simple firewalls here. We're diving deeper with microsegmentation, which lets us control access at a very granular level, even down to individual apps. And remember the core principle of zero trust: always verify, never trust. Using ACL and consistently monitoring your network for any suspicious activity is key to making sure these segments stay secure. Let's talk about tackling those legacy systems that can sometimes feel like dinosaurs in the IT landscape. Many companies have these older systems holding them back, so it's important to approach modernization strategically. There are several paths you can take, from simply retiring a system when it's no longer needed to moving it entirely to a new environment with minimal changes. Then there's replatforming, which involves migrating to a different platform, and refactoring, which is about improving the code itself. Finally, for a truly significant transformation, you might consider re-architecting, essentially rebuilding the system from the ground up. Okay, let's talk about application rationalization. Think of it as a deep dive into why you have all those applications you're running. It's not just about counting them. We need to understand if each one is truly serving its purpose and aligning with our overall business goals. We start by creating a complete inventory, then analyze the value they bring, assessing their technical fit, and ultimately making smart decisions about whether to keep, replace, retire, or simply tweak them for maximum efficiency. Okay, let's talk about how the big tech trends are shaking up our IT architectures. While frameworks like TOGAF and Zachman provide a solid foundation, we can't just apply them as is anymore. Technologies like artificial intelligence, blockchain, and edge computing are creating entirely new architectural challenges and opportunities. Think about AI. It needs powerful hardware, sophisticated data pipelines to feed the models, and then ways to actually deploy those models efficiently. Blockchain changes how we think about security and trust, requiring different approaches to identity management and transaction processing. And with edge computing, we're seeing a move away from centralized systems and towards distributed processing, which means rethinking our network designs and device architectures. Let's talk about business continuity and disaster recovery, essentially how we keep things running when things go wrong. Both TOGAF and Zachman offer helpful blueprints, but they approach AI differently. TOGAF is great for aligning the architecture with overall business strategy, while Zachman gives us a really detailed view of all the data involved. When building our BCDR plan, we need to start by understanding what's most critical, identifying the systems that absolutely must be back online quickly and protecting them from potential threats. Then, we set our TO and RPO, which tell us how much downtime is acceptable and how much data loss we can tolerate. We'll then implement backups and replication, making sure there are automatic failover mechanisms in place to switch things over seamlessly. And of course, TOGAF's ADM process helps us document everything and ensure our BCDR plan fits into the bigger picture. Okay, so we're talking about making sure our IT infrastructure is running smoothly. It's not enough to just design a good system, you need to constantly monitor it. We've got a few key strategies, things like tracking important metrics like CPU usage and network speed. Analyzing logs can also reveal problems before they become major issues, and synthetic monitoring lets us test how our systems perform from the user's perspective. Anomaly detection is particularly useful because it automatically picks up on anything unusual. There are a ton of tools available to help with all this, from Prometheus and Grafana to more established options like ELK. And don't forget, these strategies fit right into frameworks like TOGAF and Zachman, ensuring that architecture health is always being considered. Okay, let's talk about keeping a close eye on those cloud bills. It's super common to end up paying way more than you need to just because you aren't actively managing your cloud resources. Understanding the big picture, how TOGAF and Zachman can help, is key. TOGAF helps us think through the design of our architecture with cost in mind, while Zachman's framework gives us a structured view of everything involved, highlighting important dependencies. We'll cover some really practical strategies like making sure you're only using what you need, right-sizing your instances, and taking advantage of things like reserved instances to save money. Okay, let's talk about application performance monitoring, or APM. It's a really important piece of the puzzle when we're talking about building robust IT architectures like those described by TOGAF and Zachman. Essentially, APM helps us spot performance problems before they affect users. Think about it, if an application is slow, people get frustrated and leave. TOGAF's ADM process often uses APM data to make sure architecture choices are actually supporting desired levels of performance, those SLA we all talk about. And the Zachman framework? You can use that to really understand how applications fit together and where bottlenecks might exist by looking at performance metrics within the context view. Okay, let's talk about building a great digital workspace. We're using frameworks like TOGAF and Zachman to make sure we're not just throwing tools together but designing an architecture that truly supports our business goals and employee needs. TOGAF helps us align the entire strategy with what we're trying to achieve, while Zachman gives us a really detailed view of everything from data flows to how people actually use technology. Think about things like collaboration platforms, intranets, mobile access. All these components need to fit together in a way that's efficient and user-friendly. Essentially, by combining TOGAF's strategic guidance with Zachman's granular perspectives, we can create a digital workplace that's not just functional, but also truly valuable for everyone involved. Okay, let's talk about building a strong infrastructure to support remote work. When we're using TOGAF and Zachman frameworks, it's not just about picking individual tools, it's about aligning our IT architecture with the overall business strategy. TOGAF guides us through a structured approach like a roadmap to ensure everything is well planned. Zachman helps us think about how data flows across different viewpoints, which is incredibly important when teams are spread out geographically. We need robust security, think VPN and MFA, effective collaboration tools like Teams or Slack, and of course, reliable network performance that can handle video calls and file sharing seamlessly. Okay, let's talk about governing our IT, and we can't do that without frameworks. Today, we're diving into COBIT and ITIL. COBIT is all about aligning your IT with what your business actually needs, making sure everything you're building and doing delivers value and stays within the rules. It's like a control checklist for your entire IT landscape. Then there's ITIL, which focuses on how we manage those IT services, things like keeping systems running smoothly, handling problems quickly, and managing changes effectively. Think of it as the playbook for delivering great service to our users. Together, they provide a solid foundation for ensuring that our architecture is not just built correctly, but also managed in a way that benefits the entire organization. Okay, let's talk about enterprise IT portfolio management. This step is all about connecting architecture to the bigger picture, the business goals and investment decisions. Think of your entire collection of IT assets, everything from software applications to servers and data. We need to figure out which ones are most valuable, prioritizing them based on how much they contribute to strategic objectives. It's also crucial to understand what our future needs might be. This is where demand management comes in. Then, we align architectural projects directly with those prioritized demands and planned investments. And finally, we establish clear governance processes and reporting to ensure everything's on track. Essentially, ITPM gives architecture a purpose. It's not just about designing, it's about ensuring our IT investments are actually driving business value, tying in seamlessly with frameworks like TOGAF and Zachman. Okay, let's talk about picking the right vendor to help you with your IT architecture. It's super important to do this carefully. When evaluating potential partners, there are several key things you need to consider. First, look for vendors who have actually done projects similar to yours. Experience in your industry is a big plus. Then check how well their approach aligns with frameworks like TOGAF or Zachman, or maybe a combined strategy that works best for you. You'll also want to ensure they can work smoothly with your current tools like ServiceNow or Azure. Don't just look at the shiny features, really dig into the team's expertise and understand the total cost, including things like licensing and support. A good vendor will have a solid commitment to ongoing support too. It's all about finding a partner who truly understands your business goals and can build an architecture that delivers real value. Okay, let's talk about technology lifecycle management. Think of it as the roadmap for your IT systems from when they're first born all the way through to being retired. It's a key part of how TOGAF and Zachman's models help us manage complexity. TLM breaks down the life cycle into distinct stages. You start with an idea, then design it, build it, operate it, and finally review it to see if it's still useful or needs to be replaced. Each stage involves keeping a close eye on things and adapting as needed. It's all about ensuring your IT investments align with the business strategy. Okay, let's talk about IT investment planning, a really important step when you're thinking about how technology can support your business goals. It all starts with clearly understanding what the business needs to achieve and then figuring out how IT investments can help get there. We need to do a good cost-benefit analysis, making sure we're getting value for our money and not just spending blindly. Risk assessment is also key. Let's identify any potential problems before they arise. Finally, prioritizing projects based on their impact and feasibility helps ensure we're focusing our resources where they matter most. Okay, let's talk about how we apply common software design patterns when building enterprise systems. Think about things like microservices, breaking up a big application into smaller, more manageable pieces. Or maybe event-driven architecture where different parts of the system communicate through events. We've also got CQRS and layered architectures, which are pretty standard in modern development. Architectural frameworks such as TOGAF and Zachman provide really helpful structure to understand these patterns within the broader context of an organization's IT strategy. TOGAF guides you through building an architecture roadmap, and Zachman helps you define how different stakeholders see the system from various perspectives. It's all about ensuring our designs are consistent, scalable, and easy to maintain. Okay, let's talk about making sure our systems don't break when things get busy. We're looking at scalability and load testing, two really important parts of building a solid IT architecture. Scalability is all about how well something can handle increasing numbers of users or requests. Think adding more servers to cope with the growth. Load testing then simulates real-world user activity, like a flood of visitors to a website, to pinpoint where things might slow down or fail. We use different types of test steady state for long-term performance, peak loads to see how it handles sudden spikes, and soak test to check for stability over time. It's all about proactively identifying potential problems before they affect your users. Okay, let's talk about continuous integration and continuous delivery, often shortened to CI/CD. Think of it as a way to make software deliver much faster and more reliable. Basically, CI is all about getting code changes from developers into the main system frequently and running automated tests along the way to catch problems early. CD then takes the tested code and automates the process of releasing it, meaning you don't have long waits between development and deployment. It's a fundamental shift in how we think about building and delivering software, and importantly, integrating architectural guidelines into this process is key for maintaining a well-structured IT landscape. Okay, let's talk about configuration management, a really important part of building and managing IT architectures. Basically, it's all about keeping track of everything that makes up your systems. We start by defining a baseline, which is like a snapshot in time what everything looks like right now, with versions and connections clearly documented. Then we have change management. Any changes to those components go through a process where they are reviewed, approved, and implemented carefully. Regular audits ensure that the actual configuration matches what's recorded, and version control is key for tracking different iterations of things. TOGAF emphasizes this by linking it directly to its architecture repository. You need an accurate record of your architecture to be effective. And Zachman's approach recognizes that configuration data feeds into how we understand everything from a data perspective, providing context to the different views of our systems. Let's talk about securing our cloud environments. We're moving beyond traditional perimeter security and embracing a new mindset: zero trust. This means constantly verifying every user, device, and application trying to access resources. Next, we use micro-segmentation to create isolated zones within our network, limiting the impact of any potential breaches. Immutable infrastructure is another key element. It's about treating infrastructure like code, automating deployments, and ensuring everything is verified before going live. Finally, integrating security into every stage of development, that's DevSecOps. And when it comes specifically to cloud environments, we need to heavily utilize the built-in security services offered by our providers. Plus, remember container security. Scanning those images for vulnerabilities and securing Kubernetes clusters are critical components of a strong security posture. Okay, let's talk about data security specifically within cloud environments. When we're looking at architecture methodologies like TOGAF and Zachman, they can be really helpful guides, but you need to think about how they apply in the cloud. TOGAF helps us focus on tying architecture back to business goals, so we map our cloud services to what those business capabilities actually are and identify security needs based on that connection. Zachman's framework is great for understanding where data lies within your cloud across different layers and ensuring proper access controls. Key practices in the cloud include strong IAM with things like multi-factor authentication, encrypting your data both when it's stored and when you're sending it around, and using network security features to isolate different parts of your environment. Compliance is also hugely important. Make sure you're following regulations like GDPR or HIPAA, and ideally automate some of those checks to keep things streamlined. Okay, so as we're building modern applications, API are central to how things talk to each other. But just like any doorway, you need a strong lock, and that's what API security is all about. First up, authentication and authorization. Think of authentication as proving who the user really is, and authorization as determining what they're allowed to do once they've proven their identity. Next, let's talk about input validation, making sure everything coming into your API is good data, not malicious code. Rate limiting helps protect against attackers overwhelming your system with requests. And of course, always use HTTPS to keep data safe during transport and encode output to prevent XSS attacks. Okay, let's talk about how we build enterprise DevOps architectures. We're looking at three powerful frameworks: TOGAF, Zachman, and the core principles of DevOps. TOGAF gives us a solid, structured way to plan our architecture. It's all about phases and getting everyone on board. Zachman helps us understand the data landscape, ensuring consistency as we move toward automation. And then we layer in DevOps practices like collaboration and CI/CD, really bringing everything together to create a fast, efficient delivery pipeline. Okay, let's talk about how moving to the cloud changes our thinking about networking. It's a big shift. Traditional networks were pretty static, everything was in one place. But the cloud demands something different. We need architectures that can grow and shrink as needed, almost instantly. Think about things like handling traffic spikes during a sale or scaling up your services based on user demand. Security is paramount too. We absolutely have to embrace zero trust principles and make sure we're constantly verifying everything. Redundancy is also key. We want our networks to stay up even if something goes wrong. And finally, automation is essential. Tools like Terraform help us manage these complex network configurations without a ton of manual effort. Okay, let's talk about scaling databases. When our data gets really big, we're talking massive volumes of information. Simply adding more power to a single server can only go so far. That's where database scalability patterns come in. Today, we're focusing on sharding and partitioning. Sharding is like splitting your book into multiple volumes and distributing them across different shelves. We're essentially dividing our database tables across several servers, each server handling just a portion of the data. This allows us to process things much faster and handle more users. Now, partitioning is slightly different. It's like organizing one big book by putting certain chapters in separate sections. In this case, we're splitting the data asterisk with an asterisk a single server, often by separating frequently used columns from less used ones. Both sharding and partitioning are powerful tools to help you handle growing databases, but choosing the right approach depends on exactly what you're trying to achieve. Let's dive into the world of high-performance storage. It's a really important part of any modern IT architecture, and it's where frameworks like TOGAF and Zachman come in handy. They help us understand how data fits within the bigger picture. When we're talking about storage, we need to think about things like IPS and throughput, basically how quickly the system can respond to requests and how much data it can move around. Latency is also key. You want fast access times. Redundancy and availability are critical for protecting your data. And of course, scalability allows us to grow as our needs change. Finally, cost is always a factor. We need to find the right balance between performance and budget. Let's talk about data archiving and retention. It's a surprisingly important part of any IT architecture strategy. Think about all the information you collect as an organization, from customer details to financial records. You need to be smart about how long you keep things. We start by classifying your data. What's super valuable, what needs extra protection, and what can we move to cheaper storage. Then we establish retention policies. How long do we need to hold on to specific types of information, considering regulations like GDPR or HIPAA. It's not just about following rules, it's about making sure you have the right data when you need it, while minimizing costs and reducing risk. There are some key steps involved: assessing what you currently have, creating clear policies, implementing the right tools, and constantly reviewing to make sure everything stays aligned with your evolving needs. Let's talk about how we ensure our IT architecture meets the complex needs of compliance and regulations like GDPR, HIPAA, and SOX. Traditional methods can be too broad, so we need to tailor them specifically. Zachman's matrix is a really useful tool here. It helps us map those regulatory controls directly onto our systems and data flows. TOGAF's architecture development method also needs some adjustments, adding specific checkpoints for compliance documentation. Think about things like data governance, ensuring proper data lineage and access controls, robust security measures aligned with industry standards, and strong audit trails so we can meet reporting requirements. It's all about building an architecture that not only supports business goals but also safeguards against regulatory risk. Okay, let's talk about observability. It's a big shift from just watching your systems. Instead of simply knowing that something happened, we want to understand why it happened and what caused it. It's built on three key pillars: metrics, which are those numbers like CPU usage or response times; logs, providing detailed records of events; and traces, which map out the journey of a request as it moves through different parts of your system. It's all about getting to the root cause quickly. We want centralized logging and monitoring so we can see everything in one place, distributed tracing to follow requests across services, and intelligent alerting that doesn't just flag errors but helps us understand what's going on underneath them. Automation is also key, using tools like AI to spot unusual behavior before it becomes a problem. Okay, let's talk about event streaming and how it connects to our broader architecture thinking. We're seeing a huge shift in applications needing to react instantly to data in IoT devices, personalized experiences, or even fraud detection. Traditional systems just can't keep up with the speed of this information. Platforms like Kafka and Pulsar are built specifically for handling these massive streams of events. They allow different parts of your system to talk to each other without being tightly coupled, which is incredibly flexible. Now, when you're using frameworks like TOGAF or Zachman, you need to consider event streams as integral components within your architecture, mapping data flows and understanding how information is moving in real time. It's a key shift toward building more adaptable and responsive systems. Okay, let's talk about identity federation and single sign-on, a really important piece of modern architecture. Think of TOGAF and Zachman as the big picture blueprints for your enterprise IT. They help you plan strategically. SSO is essentially like a magic key that lets you log into multiple applications with just one set of credentials, making things much easier for users. Identity federation takes it even further. It's about building trust between different systems so everyone can access what they need securely. For example, if you're using Salesforce, Workday, and an internal ERP, SSO lets users log in once and seamlessly jump between them. It reduces admin work and boosts security, all while improving the overall user experience. Okay, let's talk about making your networks run smoother. We're going to look at some powerful techniques for improving performance. First off, proactive monitoring. Think of it like having a dashboard that alerts you to problems before they become major headaches. Next up, traffic shaping and quality of service, which lets you prioritize the things that matter most, like video conferencing or critical business apps. Caching can dramatically speed things up by storing frequently accessed data closer to users. Network segmentation helps keep things organized and secure. And finally, don't forget regular optimization. It's not a one-time fix. Continuous testing and adjustments are key. Okay, let's talk about how IT service management and enterprise architecture can actually work together really well. For a long time, these two groups were pretty separate. It was all about keeping the lights on, making sure things ran smoothly day to day. EA was focused on the big picture, like where the company is headed strategically. But when they collaborate, it's amazing. TOGAF and Zachman's frameworks give us a way to structure our thinking about IT, but the real magic happens when it uses those insights. Things like understanding service dependencies or prioritizing changes based on strategic goals. That's what really drives alignment between business needs and IT delivery. We can use EA data to improve the service catalog, reduce duplication, and ultimately make things more efficient for everyone. Thank you for watching.